Number 9. 7 to the what power? 2/3 power. Very good. You automatically have to know when you see a radical, you know your exponent's going to be a fraction. Or if you see a fraction as an exponent, you know that it's got to be as a radical, okay? All right, what about number 10? They like to put those on the ACT, those conjugates on the ACT. So how would I go about working out number 10? Multiply by what? Conjugate of the bottom, which is 4, yeah? Very good. Sorry, I just can't hear you all the way up here. Very good job. Very good. All right, and on the top and the bottom, we're just going to smush them all together, okay? We're not going to do any math, guys. We're just going to smush. How are we doing so far? Are we okay? All right, and then on the top, we don't want to distribute because we're hoping that something will reduce. So we're just going to keep it like this. But on the bottom, we get to do conjugate, so we don't have to FOIL the whole thing. We just say our first is 4 times 4, which is 16. And our last is how much? Just minus 5. Very good. And 16 minus 5 is how much, guys? 11. Very good. And 3 and 11 do not reduce, so we just leave it alone. You could distribute the 3 if you wanted to, though. All right, on number 11, you've got to have 4 2s to cancel out that 4 through, right? You only have 1 of them. How many more 2s do you need? Got to have 3 more. There you go. All right, what is 2 to the 3rd? It's 8. Very good. So on the top, you have 8 times 32. How much is that? 256. Very good. You have the 4th root of 256. And on the bottom, you have the 4th root of 2 to the 4th. Which, careful. Plus and minus 2. Very good. And on the top, you have the 4th root of 256. How much is that? 4. That's 4. Very good. And all of that divides. Very good. All right, put that in the same spot. We'll finish the rest of it out tomorrow. But right now, let's take our ACT 19 through 21, and let's go over those guys. All right, what about 19? It says which one does not represent a line? E. Because a square is a parabola. Very good. A square makes a parabola. How are we doing so far? Are we okay? All right. What about number 20? If you are doubling up with geometry and Algebra 2 and Trig, which I know there's one, if not 2 of us that are doing that, then you probably haven't, you're probably like, oh, what is this? But if you have gotten all the way through geometry, then this one should be an easy one for you, okay? So, you're using trig functions. Well, what's the little sing song that we use for trig functions? So-ca-coa. There you go. Okay, how are we doing so far? Are we okay? What's that stand for? What's that stand for? Sine is opposite over. All right, let me write that down. Hold on. That's what the so stands for. What's the cuff stand for? There you go. And what's the toa stand for? Very good. Don't worry, we got a whole quarter coming in 4th quarter on nothing but trig stuff. Okay? Whole quarter on that. All right, now, then you should remember from like way back in 8th grade, 7th grade, 9th grade about the hypotenuse is always the guy that's located across from the right angle. Everybody okay with that so far? All right, so let's look at our answer choices. It says we're going off of angle A, told us that in the problem. And the very first answer choice says cosine. Cosine should be adjacent, which means right next to, over hypotenuse. So what is adjacent to A? 5 over 13. Is that what F says? Nope, so that's not true. Alright, G says sine of A. Well, sine, right here, we know sine is opposite over hypotenuse. So from A, the opposite side of the triangle is 12 over hypotenuse, and that is what that one says. If you're still going through geometry, don't worry. By the time you get through geometry in this class, that will be a breeze. Don't worry, okay? Alright, what about 21? 21, if you come to the Saturday sessions, the math prep sessions, we tell you that there are 40% of the ACT problems, 40% are middle school based problems. They're middle school math, but they ask them to you in a high school level, okay? This is a middle school problem, but they ask it to you in a high school way, all right? 60% of the ACT are all the problems that we have learned from 9th grade in algebra, 10th grade in geometry, 10th grade for some of you in Algebra II and Trig, and 11th grade for some of you in Algebra II and Trig. Are y'all okay so far? So 60% is high school, 40% is middle school. They ask it to you funky like this guy did, okay? So it says, a water fountain is located halfway between B and D. Right there, halfway between. Y'all okay with that so far? And it wants to know which of the following is the location from point A. So from point A, you got to go all the way over to that dot, and then up to that dot. Everybody okay with that so far? Let's not worry about numbers. We know that the full east is 10, right? Let's call it 10 feet or 10 yards or 10 whatever. Everybody okay with that? 10 miles, whatever you want to call it. We're going just a little bit short of 10. What answer choices are just a little bit short of 10? D and E. There you go. So it's not going to be those three. Y'all okay with that so far? All right, then I have to go up. How big is that side piece from C to D? C to B, sorry. It's 9. It's 9. Because the whole thing is 12 minus this little piece is 3. So it'd be 9. I did it first. I misspoke myself. C to B, sorry. And then what's half of 9? 4.5, which the only one that has 8.5 and 4.5 is D. How we doing? We okay? All right. So that problem was an easy math problem. You just had to use your noggin, right? Are we okay? All right. Put your ACT away in a safe spot. How are we doing on ACT so far? Good. A little bit. Bad. Kind of, sort of. All right. So what we're going to do is we're going to do a very short lesson today. And you need your graphic calculator today, by the way. All right, here we go. So the very first 4 problems say to use your calculator and round, right? And the AP test, the math and science AP test wants us to round to 3 decimals. So we're going to do 3 decimals. So take your calculator, all right? And notice that it doesn't have a log base something. It just says log 5. Y'all notice that on number 1? It doesn't have a base of anything. There's no number dropped below the log, which means it's understood to be a log base 10, okay? So the only time you can use your calculator, right now, I haven't talked to you the other way yet, is when it does not have a base, okay? So we're going to hit log 5, log is next to the 7, and then hit 5, and then hit enter. And we're going to guesstimate. How many decimals do we do again? 3. So it's 0.699, but all that other stuff rounds it up, so we can just simply say it is 0.6. 7. That is the only time you are allowed to just use one decimal, is in that very rare case where everything rounded up. All right, what about number 2? Plug in number 2. What's log of 0.3? Negative 523. Wait, why is it negative? Because it's a decimal. Remember when we did this, guys? Like, look, watch right here. Remember when we did that? And you're asking yourself 2 to what power is 8 to the negative 1? And we got negative 3. You all okay with that? That's all we're doing. All right, what about number 3? What you get? Everybody agree with that rounding? Do we agree? All right, and last one, number 4? We agree with that rounding? But why is it negative again? Because it's a fraction, it'd be 1/2, right? How are we doing? We okay? All right, well, that was easy enough. Okay, now let's go to the next ones. And here is what I want you to understand. I don't want you to go ahead and, well, you can't go ahead right now. But once I teach you how to do one problem, I don't want you to go ahead because you're going to have 2 of the exact same looking problems next to each other, but they're going to work very, very differently, okay? So here's my question to you. This is the problem that we just did on the test on Tuesday. How is it different from 5, 6, 7, and 8? Did you?
If you there is an actual exponent that you can raise 2 to equal 16.
Very good. 2 to what power is 16? 4. So you could just tell me that answer is 4 and be done with it, right? Y'all okay with that? But look at number 5. We do not know a power of 4 that gives me 19, right? We know a power that's close to 19. What power is close to 19? 4 to the second would give me how much? 16. So I know my answer is going to be 2 point yada yada yada. I know that already. My answer is going to be 2 point yada yada yada. All right, here we go. You can do anything to a problem you want to as long as you do it to both sides. So I can put a log on one side. I can put Christmas tree on one side as long as I do the exact same thing to the other side, right? As long as you keep them equal. And then think back to yesterday. The whole reason we want to do this is because we had 3 properties yesterday. 1, if you were multiplying things together, you could split them apart by adding. 2, if you were dividing things, you could split them apart by subtracting. And the third one was a power rule, right? When you had a power, it gets to go in the front. Very good, very good. So we can write this as x log 4 equals log 19. And yes, this is the only time you can write that. That x is an exponent to begin with. So that is perfectly okay. All right, then this says x times log of 4. How do you get rid of log of 4 that you're multiplying? Divide it. There you go. To get x by itself. Those log 4s cancel out. And so you're going to type in your calculator, log 19, close your parentheses, divided by log 4. Look at that. Did we get 2 point yada yada yada? All right. Very good. So the way we're going to write our answer is x is approximately, what was that yada yada yada? 124? 124. Okay. All right, so the reason I want you to estimate is 1, so you can check your work, and 2, if they gave you that problem on the ACT, you could already kind of mark through and know which answers should be the right one, okay? Let's look at number 6. All right? The reason we're going to work this problem like this is because we do not know a power of 3 that will give me 15. Are y'all okay with that? But I know something that'll get me close. 3 to what power will get me close to 15? 3 to the second power is 9, right? So I know it's going to be 2 point something. Are we okay with that? All right, here we go. We got log of 3 to the x power is equal to log 15. And then we got a power property that says this power can go in the front. Very good. I don't want it. I want x to be by itself, so I'm going to divide by log 3. And I already know that x is going to be 2 point something. What are those decimals? 465. Does anybody else agree with those decimals?
Mm-hmm.
Yes? Okay, good. Yes, ma'am.
How do you figure that out?
Run your calculator.
Okay, I see.
Got it? Got it. All right, 2 more. Here we go. Let's look at 2 more. What about number 7? Why do I have to work it this way? Because you don't know 6, so you don't know the power that'll give you 42 because it's a decimal, okay? So you do. All right, bring that x to the front. Divide by log base of log of 6. How are we doing so far? Okay. And I know my answer is going to be 2 point something. The reason they keep being 2 point something is because I don't want to give you crazy large numbers.
It's 2.086.
Very good. Why was number 7's decimal so close to 2? Like it's 0.02, it's 0.286, but like number 6 was like 0.465. Why was this decimal so much bigger than this decimal? Huh? Not because 6 is bigger. 6 squared is 36, which is closer to 42, because the decimal needs to be smaller. Here, 3 squared is 9, which is a good distance away from 15. Are y'all okay so far? All right, here we go. Last one, number 8. Last one. Why are we working it this way? Because we don't know the power of 5 that will give me 62. So here we go. I know that 5 squared is 25, and 5 cubed is 125, right? So it's going to be the 5 squared, so I know my answer is going to be 2 point something. What'd you get?
2.564.
564?
4, yeah.
And why is that decimal so big again?
Because it's larger, because it's further away.
Very good. The 5 squared is 25, and 62 is a really good distance away from 25, so that's why it's a bigger decimal. We okay? I'm trying to give you some pointers, that way you can probably go through the ACT pretty much for real quick like, okay? All right, do we need to do that bottom line?
No.
Okay, good. Let's call it. All right, let's go down to the bottom. Way down there at the bottom. Way down there at the bottom. All right, did you notice when we just did those 4 problems, did you notice that we were dividing log of a certain number over log of a certain number every single time? Did you notice that? Do you notice where we got those numbers from? Where did the 19 and the 4 come from on number 5?
To each side of the problem.
Where did the 4, what was the 4 though? And number 5, what was the 4 to begin with? He was the base, and he went on the bottom of the fraction. Get it? Base goes on the bottom of the fraction. You okay? Good so far with that? All right, so let's look at this guy. Here we go. Let me ask you this question. What if I gave you this?
So it's just log of 3 below log. I mean, like log of 27 over log of 3.
Yes, not on this one though. I don't have to. What's the question? Very first thing we asked ourselves when we first learned logs.
What
What power of 3 is 27? And what's my answer? 3 to the power of x is equal to 27, which means that answer is just 3, right? Yes, sir.
I thought you said that number 5 didn't have a base and 4 was.
No. To begin with, the base was 4 to the power of x. When we rewrote it, the log didn't have a base. Does that make sense? Okay. But to begin with, it had 4 was the base to the power of x. Okay? Alright, so let's look at this one. If I give you 2 of the exact same problems, they look identical, right? The only difference is, why could I just say my answer was 3 here? Because you know it already, right? The question you ask yourself is 3 to what power equals 20? Do we have a 3 to a power that gives me 20? There is one, but we just don't know what it is because it's a decimal, right? So, you could do one of 2 things. You could either, this looks exactly like what we just did, right? You could work it the same way, or you could use your formula and do log 20 over log of your base, which is 3. Base goes on bottom, right? So it's the only way you have to remember it. Base goes on bottom. And then divide those into your calculator. 2.727 sounds about right. Why is that decimal so big? Because 3 squared is 9, and 20 is really far away from 9, right? Alright, what about 14? 14, ask yourself the question first, because there's going to be 2 of them right next to each other. So, is there a power of 6 that'll give you 8? No. That's why we're using this way. So we're going to do
log of 8
over
log of 6.
And your base goes on the bottom. 6 was your base, so that goes on the bottom. And I know 6 to the first is 6. So I know my answer is going to be really close to 1 point something, right? 1.161? Okay. There we go. Alright, last one. Here we go. Ask yourself the question. Do you have 5 to a power that'll give you 140?
No.
But I know 5 to the third is 125, right?
So is it
So
very
it'd
close to 3?
3 point, really close to 3, right? So here we go. We got log of 140 over log of 5, and I already know it's 3 point something.
3007.
Yeah.
3070. There we go. How we doing? We okay? All right. So that's it for our notes. We were going to do a checkpoint today, but instead we are going to work on our projects. And when I call your name, you're going to bring me your whole notebook, and I'm going to check through your homework. And if there's one that's really far gone, we're going to work through it together. Okay? Everybody good with that? All right. So if there's several of them that are wrong, then I'm going to tell you come see me for 0 period one day, and we'll work through those. Okay? How we doing? We okay with that? All right. Then